Let's begin. All right. So histograms and frequency polygon notes. We already previously talked about when do you do a histogram or when do you use a histogram? Remind me again. When do we use a histogram instead of a bar chart again? When do you do that? Let's go, Jack, do you remember? When do you use a frequency or a histogram? No. It's the other way around. So, bar charts is for categorical. Bar charts equals categorical, which means gaps. Think about it, it has to have gaps. And you think about categorical's names, labels, so they have to have gaps. Whereas histogram, right, as a note for you to remember, for those who want to do exams, this is one of the first things they'll test, is numerical. No gaps. A frequency histogram is similar to a column graph or bar chart with the following key differences. Gaps are, what's that? N left between the columns. No, it's not. Except for a... I know what I want to say, but I'm not sure what words I was using at the time. What's that? Gaps are... Oh yeah, you're probably right. It's not. It just looks funny. Gaps are not left between the columns. So I should have just said no gaps between columns. This was so unnecessary. It should have just been no gaps. I'm going to go fix my notes. All right, so it should be no gaps between the columns except for the very start. So when you do your histogram, there has to be a gap. First column and the y-axis. Just put that as a note so that you remember. But there should be, except for, I don't know what the H here is, unit space. Half unit, that's right. A half unit space before the first column. So if you usually do units of 1, then it has to be half. If it's units of 5s, then you have to half 5. So it has to be half a unit space. Frequency is always plotted on the vertical axis. So that means here you're always looking at frequency. I'll just do frec for frequency. That means that numerical data is only one set of data. So that means the number of data you're looking at. So for example, what's a numerical data? Number of siblings you have. So you can have 1, 2, 3, 4, etc. Okay. I know that's discrete, and so you can actually draw them separately as well. Frequency is always plotted on the vertical y-axis to help you remember which one it goes on. Each column is drawn in the middle of the scale. Okay, so each column, so the way I've sort of drawn it, each bar has to be in the middle of the scale. Okay, so I'm going to write here middle. Needs to be in the middle of the scale and marked on the horizontal axis. See example later. If columns are colored, must all be done in... Yeah, that's right. So if the columns are colored, then you must make sure they're in different colors. This is why histograms are usually used for, and we already established this, is numerical data. Especially continuous data. So if you're wondering why it has to be continuous, think about the number line. When we're doing frequency, if it's continuous, for example, measuring your height. So your height could be, say, between 130 centimeters to 140 to 150 to 160 to 170. You guys can range anywhere in between. So it's not just 130, 131. You might be 130.05. You might be 130.1. You might be 140.7. So there's a continuum between them, which is why when you draw your bar charts, they will then connect with each other. That's when it's, especially when it's continuous data. Okay. All right. So here are two examples that you see for year 11s and year 12s. You guys will be learning to sketch both. It's called grouped versus ungrouped. Or another way of thinking about it is you can have them being in intervals. So say 18 to 23, 23 to 28, 28 to 33. Or they could be segregated. So numerical, remember, you can have discrete and you can have continuous. If it helps you to understand, write this as discrete data versus continuous. Can you see how these are linked? It goes from 18 to 23, 23 to 28. They're all linked. But if you have a look at this axis, that's just 0, 1, 2, 3. And notice how 0 wasn't on exactly where the start is. There's that half unit space. Okay, so I'm going to write here half unit space. Okay, and these are called discrete because they're separate. So if I said the number of siblings that you have 0, you have 1, you have 2, you have 3, but you don't say I've got 1.5 or 2.5, okay, or 2 1/3. So it has to be discrete. But notice the columns are all connected. There's no gaps in between, and they're in the middle of each one. Versus this one is the only time where you don't have to do it in the middle. It just has to sit between the two ends, 18 to 23, 23 to 28, 28 to 33. Okay, so both year 11s and 12s, that's what you have to do. Again, all of this you can type on Excel and sketch it, but they do require you to do it by hand. So you need to label the scale. You need to label the axes. So make sure you have the y-axis labeled, x-axis labeled, and a title. Okay, so I think these two pictures is a nice summary of what skill you're doing in 5.4. So 5.4, read a frequency table, and then draw out a histogram. All right, so we've covered when to use histograms, numerical data. What type of data can you get? You can get discrete or you can get continuous. Continuous means linking. Discrete means not linking. Just make sure the bar's in the middle. Not for this one. Okay? All right, here we go. This is for the year 12 component. So if you're looking at the year 12 exercise and you're doing the 5.4 on my OneNote, then frequency polygon adds on just another little bit of data. A frequency polygon is a line graph that can be drawn by joining the center of the tops of each column in a, what's that? They are especially useful for comparing. Oh, histogram. That's right. So notice these lines here. That's called a frequency polygon. And all we do is we essentially put a dot at the very top of the bar, but it has to be in the center. So the center of each bar is connected, but notice the start as well. There's a start. And there's also an end. What's useful about it? Without the bars, you can actually look at trends. You can look at the shape and how it's sort of growing or decreasing. That's usually how the stock market's usually drawn. So if you look at the stock market, you'll see them in lines rather than bars. Yeah. And that's, yeah, by God. So that's how you can see. You can see that trend, if it's a steep trend or if it's a slow trend, because the line dictates, is it a slow growth or is it a high growth? That's why when you see things like that, you're like, oh yeah, that looks really impressive. I should buy and sell because it's showing high growth. But it's high growth because the lines are very steep. Had it been like this, you can already tell that's low growth. In fact, this is a negative growth. It's dropping down. But this is showing how slow it grows. That's why flatter the line, the better for us to read. So that's why that frequency polygon is useful in that instance. So it's useful for comparing data, especially if you're comparing multiple things, like multiple companies. If you're looking at stock markets. Ensure that the start and end of the frequency polygon start on the x-axis half unit or halfway between before and after the columns. Okay? And that's the only year 12 component. That's pretty much 5.4. So if we look at the contrast between 11 and 12, 12s do this extra bit. They add in a polygon. So if you wanted to, in your year 11 questions, you can also add in polygons as a practice. If you plan to do foundation next year, worthwhile just practicing your own notes. Otherwise, what did you have to take out? The examiners really want to know, do you know when to use histogram? Do you know the details of what a histogram must have? Those are the main things. So this 2 pictures here is pretty much what you take out for the exam. The drawing part, draw a few, get good at it, and that's it. You don't have to do a lot of them. I'm just really assessing if you know how to draw one and if you can identify one. Yeah? Flip over the page. Let's do a practice. Here we go. So this is for both 11 and 12. This is called a frequency table. What are we looking at? We're looking at an appropriate graph for the data given. So we've got number of books read over 6 months. So you got 0 first at the beginning, 1 month, 2 months, 3 months, 4 months, 5 months, 6 months. After 6 months, let's look at the frequency. So number of books read over 6 months. So in the first one, we've only read 2 so far before the first month. After a month, I've read 9. After 2 months, I read 15. After 3, it's 12. 4, I gave up and I started reading less. So I read 8. By the 5th month, overall, I've read 3. And the 6 months, I've read 1. So obviously, there's a decline in motivation after 6 months. Obviously, I peaked at 2 months. And in total, I read 50 books. Okay? Now, looking at that, you can extrapolate information, but usually a graph tells us a lot more. That's why we do a histogram. Why do we do a histogram? Again, these numbers. 0, 1, 2, 3, 4, 5, 6 is not categorical. Clearly, this is numerical. But what type of numerical is this? Discrete or continuous? Which one is it? So let's go with Michael. Discrete. Very good. This is discrete because it's not anything in between. It's 0, 1, 2, 3, 4, 5, or 6. That means when you sketch a histogram, it's going to be like this one. Okay, so the numbers of the scale on the axes should be individual and the bar should be in the center. Not like this one. Okay, so you got to first determine, is it continuous or discrete? And like Michael said, it's discrete. So you should be drawing something like this one. Okay, all right, here we go. What type of data is this? So you said numerical, but specifically, we know it's discrete. Which type of graph is more appropriate to display the data, bar chart or histogram? Hopefully, at this point, I've drilled in histogram. It's because the x-axis is continuous. Yeah? Bar graphs is only for labels. That's why they're separate. Histograms have no gaps. So histogram is more appropriate. That's for a year 11, year 12 exam type question. So I may ask you to choose one, and I might not even give that hint. Okay, so I won't even say bar chart or histogram. I'll just ask you, choose an appropriate graph to display the data. And if you choose it wrong, that's when I know that you don't understand when to use for a categorical or for a numerical. Okay. Part C, draw the graph and let it add a frequency polygon. Here we go, let's draw a frequency. So from 0, I want 2. Now remember, when you draw the bar, put a half gap. Okay, so you shouldn't start here, you should start halfway. And it's 2, so it should be like this. Use a ruler. I obviously don't have a ruler here, so I'm just going to do it like this. 2, what's the next one? After 1 month, it's 9, then 15. So 9 is roughly around here. So I got to draw a line. Wow, that's terrible. 9, notice the bars. The scale is in the center of each axis. 15. After 15, it is 12, then 8. 12 is exactly here. 8 is exactly here. That's nice. Then 3. And finally, 6 is 1. Okay, so this is the year 11 skill. So when you're doing this on your own exercise book, scale the x-axis. If you have a grid book, that would be easier to draw as well. Don't forget to label frequency on your vertical axis, number of books on the x-axis, and then what is the graph about. So the graph is about the number of books read over 6 months. Okay, if you miss any of those, I'll penalize you, especially for the SAC. I'll be looking if you can draw a proper graph, and I'm looking for details. So I'm looking for the gap, I'm looking for the center, I'm looking, are you using ruler, I'm looking at, are you scaling it correct? If you're doing it like a free drawn thing, I'll penalize you for that too. Okay, so I'm looking for clear details that you can do this properly. Okay, obviously if you're doing your own books, you can do it however you want, but when it comes to an assessment, I expect you to do it properly. So that is year 11 content, and then if you want to add on a year 12 content, frequency polygon, start from the center. So at the start, you've got a gap. Center, 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 and then don't forget the end as well. You need a center one there too. Connect the dots. So here we go. I do a straight line, a straight line, a straight line, straight line, straight line, straight line, straight line, and that is your frequency polygon. Year 12. I'm going to write here year 12. Okay. So that's what they'll do at year 12 when they say frequency polygon. If you look at the exams and you see that question, well, that's all it means. Okay. It gives you a better way to read the trend, and you can also compare with other graphs as well. That's what's beneficial about it. All right. And then we got one last example, isn't it? Is it just one last? Yeah. All right. Your shot now. I'm going to pause the video as you copy that down. I want you to do the next part of the question. Same idea. There's a frequency table, shows maximum daily temperature in Melbourne. Construct a frequency histogram and then a polygon on the same set of axes. Class set of marks on an exam. Draw a frequency histogram polygon on the same set of axes. Okay, I'm going to pause the video and we're continuing. So, first thing is to draw the graph. So it shouldn't be in the center. So as you're drawing this, I expect it to start at 18. This means, for those who don't know, means 18 to, and then this means less than. So 18 to 23, but not including 23 is what it's saying. So 18 to 23, we should have 14. So 14, we go nice vertical line, across, down, 14, 23, and then from 23 to 28 is 8. Here we go. And then from 28 to 33, we've got 5. So 5's in between. And then 33 to 38 is 3. And then lastly, 38 to 43 is 1. If you did a frequency polygon, starting from the center, to 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 the center, and then finally, don't forget the end center as well. All right, can I get a show of hands who got a graph that looks similar to that? Hands up. Good, that's 1 mark. Okay, so 1 mark, that's just drawing it appropriately. So it shouldn't be in the center, it should have been connected because it's a continuous data. Good. Second mark is labeling. Did you label frequency on the vertical axis, and on the bottom it should be temperature? Hands up if you labeled. Good, if you forgot to label, I'll take off a mark because the graph means nothing if you don't have the label. But then even after you have a label, so that's 2 marks, even after you have a label, great. Well, what does this tell me? What's the point of reading this graph? The title is important too. So in this case here, it shows the maximum daily temperatures in Melbourne in December. So you should say here something along the lines of max daily temp or temperature in Melbourne. That's good enough unless you want to write December as well. That's a very detailed title. But regardless, now someone looks at this and say, oh yeah, all this represents daily temperatures in December, specifically in Melbourne. Then they can read, oh yeah, these are the frequencies. How many days in December had a max temperature of 14 in December? How many days in Melbourne in December had a temperature, max temperature of 8? Okay, that's what this is telling me. Otherwise, without the title, this doesn't really mean much. I could just say, oh yeah, at 28 degrees, or 23 to 28, we've got 8. Well, what does 8 days or 8 represent? Frequency doesn't tell you what it is. So having a title tells us now we know it's 8 days in December has between 23 and 28 degrees. Okay, so that's what I want you to be able to do. That's your 3 marks. So being able to draw it appropriately, using a ruler, scaled. Okay, I gave you the scaled graph, but you're going to have to do it yourself. Make sure it's scaled. That's 1 mark. 2 marks for labeling, and then your title, 3rd mark. Technically, if I had to put it all together, it could be scaling is 1 mark, graphing is 2 marks, and titling or labeling is 3 marks. But I just wanted to emphasize why the title is important. Cool? All right, team, that's pretty much 5.4. I'm going to stop the video there.